Okay, so iteration involves the repeated composition of a function f within itself. For example, one iteration is f of x, composition of functions, like we learned about in first semester. Two iterations is f of x. So we can use iterations to generate a sequence recursively starting with the initial value. So this definition looks a little dense, but I don't think it's really too bad here. So what we're going to do, we are given our original function, and we are given a first term, and they ask us to find the first three iterates. So what we're going to do to find the first one is we are going to find f of x0, f of what the x0 is that they give us. So in my function, I'm going to plug in the value they give me for x0, and that will be 2. So I have negative 3 times 2 plus 1, so I have negative 6 plus 1 is negative 5. So that is my first iterate, so this is what we call x1. Now to get the remaining ones, all that we do is to get the next one, we plug in f of x1, just what we found here. This is x1. And now I'm going to plug it into the same formula for x and get the next one. So I have negative 3 times negative 5 plus 1. Negative 3 times negative 5 is 15 plus 1 is 16. And that gets me my second iterate. That gives me my x2. And then finally, to get the third one, all you're going to do is you're going to plug in x2 into the same formula, and I'm going to plug in negative 3, what I found for x2, 16, plus 1. So negative 3, times 16 plus 1, negative 47 gives me x3. That is my first three iterates. So what you're just going to do is you're going to keep plugging in, and every number that you generate, you're going to plug it back into the original function to get the next term. And that's why it's a composition of functions, because we're using what we have previously and plugging it into a new formula. So not so bad. The next problem is a DIY. I will tell you the next three, and hopefully you guys can get the same numbers that I do. The first one I get is 4. The second one I get is 11. And the third one I get is 116. So make sure that you can do it on your own. This will be our function, and we're going to start at negative 1. And just be careful. Negatives go inside parentheses when raised to powers. We don't like to do that, but you have to do that because that will take care of your signage. Alright, and now the last problem that we are going to do, I will do with you guys. So it says an online music service has initially 5,000 annual members. Each year it loses 20% of its current members and adds 5,000 new ones. So the first thing we're going to do is write a recursive rule, just like we did at the beginning of this section. Then we're going to find the numbers at the 5th year and describe what happens to the number of members over time. Okay, so let's do part A first. So it says, all right, we have initially 5,000 new members. So I'm going to say my first term is 5,000. And each year it loses 20% of its current members and adds 5,000 new members. Actually, why don't we label... I think no, we're okay. We'll leave... I think we'll leave it like that. That's okay. Now let's make the rule. So if it loses 80%, we're going to write it as in terms of like a gain. So if it loses 20%, it gains 80%. And it's 80% of its at 80%, and then we're going to lose 20%, of its current members. So that's 0.8 times the current members. So this will be a to the n minus 1. So this is the previous year members. And like I said, this 0.8 is us losing 20%. If I lose 20% from 100, you get 80. But I lose 20% and I add 5,000. So nothing special, I just add 5,000 here at the end. Okay. That's our recursive rule. There it is. Both parts of it, because you need a first term, you need a starting term, and then you can generate each next term by using the formula. So then it says, all right, find the number of members at the start of the 5th year. Okay, there's really no short way to do this. You got to do this every single time like we just did iterations. You got to plug in A1 and get A2, you got to plug in A2, get A3, so on and so forth. So if I want to find A2, my second year, I'm going to do 80% of 5,000, my previous year term. And I'm going to add that to, 50,000, and I'm going to add that to 5,000. Well, when I do that, we can plug that in our calculator, I get 45,000 members in my second year. A3, my third year, 80% of what I had the previous year. So I've got to use the 45,000 to get my third term. I've got to use the previous year's amount. And then I'm still going to add that 5,000 here at the end. And when I plug it in the calculator, I have 41,000. And then I'm going to repeat the same thing for A4. 41,000 plus 5,000. And I'm going to get 37,800. And then finally, my 5th year, 0.8 times what I got previously in the 4th year. 37. I was writing down the answer. I'm sorry. 8,000 plus 5,000. And I get 35,240. So like an iteration like we did on the other page, using our recursive rule. There's no other quick way to do this. We can't just like plug in 5. We can't do anything like that. We have to get the previous year's term. So imagine if we gave you like the 10th year. You guys would have to be doing this for a long time. But we wouldn't do that. Last problem, C. Describe what happens to the number of members over time. So we can say that the number of members decreases. And what happens that's kind of neat, I'm not going to do this, but I think you can do it on your own. You can see it, and it kind of works out nicely. If you continue past 5 years, the number of members goes to, or stabilizes, we'll use a fancy word here, 25,000 members. So if you found A sub 6, A sub 7, A sub 8, A sub 9, A sub 10, you would find that those numbers are getting closer and closer to 25,000, and that would be what happens to the number of members over the course of time. All right, so that's it. Obviously, this is a big problem. We will do a couple of these like this tomorrow in class. But yeah, that's it. Be ready to come in and get what we need to get done tomorrow. Thanks, guys.